Alright, today we're going to be doing Recursion-2. It has a good 8 problems here. So let's get straight into it. These are going to be some harder recursion problems, of course. Okay, so given an array of ints, is it possible to choose a group of sum ints such that the group sums to the given target? This is a classic backtracking recursion problem. Once you understand the recursive backtracking strategy in this problem, you can use the same pattern for many problems to search a space of choices. Rather than looking at the whole array, our convention is to consider the part of the array starting at index start and continuing to the end of the array. The caller can specify the whole array simply by passing the start as 0. Okay, so go ahead and try this problem. If you need to use the hints, go ahead. But yeah, I would go ahead and really try and think about how to do the solution and try and solve it on your own. But it is using a new kind of strategy that we definitely have not used before. So go ahead and pause and try this one. Okay, so basically we want to see if there's a group that sums to the given target. So what I'm going to do is I'm going to go through the array, but at every junction I'm going to split, sorry, not every junction, at every index, I'm going to do a split. Basically I'm going to split into two paths. And in one path, like imagine we could, split reality into two like parallel universes. I'm maybe making this sound a little too cool. But basically at every index I'm going to split into two worlds, one in which I do take that, like one in which that number is part of my sum, so that is included in the group that's going to sum to the given target, and then another world in which I don't include that number. And I'm going to do that at every index in the array. So I'm going to like keep splitting and splitting and splitting into a bunch of different possibilities and see if in any of those possibilities, yeah, in any of those possibilities, if I get a sum to the given target. So that's going to be the strategy here. And then, so my base case is going to be if the target is 0, then it definitely is possible to create a group. The group is just going to have nothing in it. So if the target's 0, we can return 0. And then otherwise, if the start index is equal to the length of the array, well then I'm going to return false because I know that the target, sorry, I already checked that the target's 0. So I know that the target's not 0, and therefore, I made it to the end of the array without getting the target, and so therefore, I have not found a valid group. Okay, so those are our base cases, but now we can actually get to work. So basically, as I said, I'm going to split it up. So I'm going to have two booleans. One's going to be, these are just like the results of our two splits. So in one split, we're going to take the number at num's start. Start is the name of our index, and I kind of don't like that. I'm going to call it index. Um, oops, index. So one's going to be nums at index, and the other is going to be, in one group we're going to take the number at the given index, and the other group we're not. So taking it, what should I do? Let's say with index. I'll call it with index with the value. I'll just call it with. Okay, with the value nums at index. And so what I'll do is I'll say um, equals if I can find a group that sums starting at the next index, searching from the next index onward. Can I find a group that sums to target minus nums at index? So in other words, this is kind of like the other problem. I don't remember what it's called, but where we reduce the goal down until the goal got to 0. So I'm taking the target and I'm subtracting from the target the number I just had. That way, in other words, instead of like moving towards the target, I'm moving the target closer by whatever amount that I'm adding into my group until that target eventually gets to 0. And then without, if I don't take the number, all I'm going to do is I'm going to get a group sum starting at index plus 1, and I'm just not going to move the target closer. So that's how I indicate that I'm not including this number because it's not part of my sum, so it doesn't cause the target to move closer. And then all I need to do is return with or without. If I can make a sum that sums, pick a group that sums to target with taking this number or without taking this number. And so here are my two splits. And so it gets kind of interesting because this is the first time we've had like two recursive calls, or I don't know if it's the first time, but two recursive calls like that are both going to happen within the same first recursive call. So it's like each call is spawning more calls until, we eventually get to the end of the array. So, forgot a semicolon somewhere. Line 7, I need an equal sign. Okay. And, okay, so sorry. If the target equals 0, return true. We have found a group that sums to the given target because there's nothing there. The target's 0. Of course, we can sum to that. And then that's how we could do this one. Now, if we inline this, if we inline these, and we say width, we put that there, and we put this here, then this is actually going to make our code more efficient because we're going to take advantage of short circuiting. So in other words, only if width returns false will without be evaluated. So that'll make it a bit more efficient. But that's, again, not something you really need to be worrying about here. But yeah, we could inline it like this. And that's how we could do this one. Yeah, so this part here, this is equivalent to what I have. Let's see, actually, is it? It's not, but yeah, this actually will also work. Okay, so, and then they do the same idea. There's a bunch of comments if you want some more, yeah, some more ideas. Nums at the index is chosen or not. And so this gives you another description of what's happening here. So that's how we could solve this one. And so now, well, first of all, don't worry if you didn't get this strategy on your own or you had to use the hints, it's fine. But now that you have this kind of idea in your head, then maybe the next ones will be easier to solve and you'll be able to come up with solutions on your own if you didn't for this one. Okay, so is it possible to choose some group of ints beginning at the start index such that the group sums to the given target? However, with the additional constraint that all 6s must be chosen. Pause and try this one. Okay, so of course, similar idea to the last one. I'm going to say that, so I don't want to say if the target equals 0, just return, because even if the target equals 0, I might be forced to take 6s later. So like, just because I've reached the target at some point, I might be forced to take other 6s later that make me go past the target. So I don't want to say if target equals 0, because just because target equals 0 doesn't mean I found it. But if I'm at the end of the array, so I'm going to rename this to index because I like index. If I'm at the end of the array, did I tell you to pause and try this? I think I did. Do that if I didn't. Okay, so if we're at the end of the array, then we just need to return if the target equals 0. Because if we're at the end of the array, well, if we've summed a target, we're good. If we have not, then we're not good. So that's why I'm just returning the value of target equals 0, if target equals 0. So now what I'm going to do is I'm going to say, okay, if the number here is a 6, then we got to take it. So we don't have a choice. We're not going to split into two different realities. We're just going to take this 6 and move on. We don't have a choice. So I'm going to say return groupSum6 if we were to start at index plus 1 with the same array, and the target's going to be subtracted by, well, 6, because we took this 6. And I could also say, subtract by nums index, but I know that nums index is a 6, so I can do that. And then what I'm going to do is, okay, otherwise it is not a 6, so I can either take it or leave it. And so I'm going to say return group groupSum6. So I'm going to, this first case is going to be if I take it, so target minus nums index, or the possibility where I don't take it, so group sum6 with index plus 1, and the same target. So that's going to be the idea here, and that is how we could solve this one. We can omit these curly braces. Okay, so yeah, that's how we could do this one. Very similar to the last time, except that if we only have a 6, we're forced to take it. We don't like have one possibility of taking it, one without taking it. We have to take it. So that is how we can do this one. Okay, so is it possible to choose a group of sum in such that the group sums to the given target with this additional constraint? If a value in the array is chosen to be in the group, the value immediately following it must not be chosen. Ooh, okay. Pause and try this one. Okay, so I think what this means is that if we take a group, instead of incrementing index by 1, we increment index by 2, so we skip over the next one. That's my idea. I think that will work. So similarly to the last one, so basically it's going to be if start is nums.length, we're going to return if target equals 0, like before. And then basically if, here's what we'll do. So if we take it, we can't take the next one. So I'm going to do that. I'm going to do Boolean with and without. We can simplify it later if we want to. So with, if we do take it, then I'm going to say if groupNoAdj, I'm going to start, so instead of, and let me change this to index. So what we're going to do is we're going to increment index by 2, so we can't take the next one. Same nums, and then target's going to be, we're going to subtract nums at index. Okay. So that's good. So that's what happens if we do take it. And by the way, because we're adding 2 every time, there's a possibility we might overshoot nums.length. So I'm going to say if index is greater than or equal to nums.length here. Okay, and then without, it's going to be if we just do groupNoAdj, index plus 2, sorry, index plus 1 this time, nums, and don't change the target. And then just return if we can make it with or without taking this one. And I believe that'll work. Yeah. So that's what we can do here. Of course, we can inline it as well. So we could do this here and take advantage of short circuiting. So yeah, not that much code, but you know, some interesting things to think about. All right, is it possible to choose some group of ints such that the group sums to the given target with these constraints? All multiples of 5 must be included in the group. If the value immediately following a multiple of 5 is 1, it must not be chosen. So, okay, pause and try this one. Okay, all multiples of 5 must be included in the group. So wait, I think it means if the value immediately following a multiple of 5 is 1, it must not be chosen. I think it is referring to the 1 must not be chosen, not the multiple of 5 must not be chosen. I kind of wish that was clearer, but I'm assuming, since it says all multiples of 5 must be included, I'm going to assume it means that the 1 must not be chosen. I assume. Again, wish the instructions were clearer. Okay, so if, I'm actually going to call my index I now. So if I equals nums.length, return target is 0. Okay, and then what I'm going to do is I'm going to say, okay, so all multiples of 5 must be included in the group. So if nums mod 5, or remainder 5 is 0, then it must be included in the group. And so what I'm also going to say is if the value immediately following this number. So if, well, first of all, there is a value following this number, and that number is a 1, sorry, no, so the next number is a 1, then it must not be included. So I just need to return if I can make sum, skipping the next 2 values, and including this 5. So including this 5. So pass the same array, target minus nums I. There we go. Okay. So if the next one's a multiple of 1, sorry, no, if the next one is a 1, it must be chosen. Otherwise, I can have 2 possibilities. I can, well, actually, no. I still have to take the 5 either way. But I can now on the next one, on the next number after this multiple of 5, I have a choice. So I'm still going to do only one possibility, I plus 1 nums, and then target minus nums I. The only difference is I'm skipping the 1 here, or in this case I'm not skipping the 1. So that's what we'll do here. And then I'll do otherwise. So otherwise nums otherwise this number is not divisible by 5, and this should be nums I. Otherwise nums I is not divisible by 5. And here's what I need to do. I basically have a choice. I can include it in the group or not. So return groupSum5. If I do include it, it'll be I plus 1 nums target minus nums I. Or I don't include it. So groupSum5 I plus 1 nums target. Okay, there we go. That is how we could solve this one here. All right. Is it possible to choose a group of some int such that the group sums to the given target with the additional constraint? If there are numbers in the group that are adjacent and with the identical value, and they have the identical value, they must either all be chosen or none of them chosen. For example, with the array 1, 2, 2, 2, 5, 2, either all the three twos in the middle must be chosen or not, all as a group. One loop can be used to find the extent of the identical values. Okay, pause and try this one. Okay, so let's go ahead and do this. I'm going to put a helper method, because helper methods are totally allowed, and I'm going to use my one loop in this helper method. So it's going to say end of clump, and it's going to take the start index of the clump. So it'll take the array and the start index of the clump. I really wish they put the array first, because they do that like on all the other problems. But anyway, so I'll say value at start. I'll call this just in is the value at the start index. And I'll say for int I equals, and let's see, do I want to return the index that is actually the index of the last number in the clump, or the index one after it? I'll do the index one after. I'll say for int I equals start plus 1, I less than nums.length. Or actually, I'll say int in equals start plus 1, and then I'll say while end less than nums.length, and nums at end equals the number at start. I'm going to get rid of my in variable. Then end plus plus, and then I just return the end when I'm done. So that'll give me the index right after the last value in this clump. Okay, so here's what I'll do. I'll say, again, same base case. If start equals, I'll say greater than or equal to num.length, return target is 0. Okay. And then basically, I'm going to treat everything as a clump, even if it's only one number. There's no really harm in doing that, so that's what I'm going to do. And so I'm going to say, okay, I can either take this clump or not take this clump, because every index starts a clump. Or not every index starts a clump, but every index is part of the clump. So, okay. So I'll say end of clump is going to be at the whatever index this returns. So nums index. I can call this start. Yeah, that's fine. Start. Okay. Okay, so now I have the end of the clump. And what I'm going to say is basically the value of the clump is going to just be whatever the first number in the clump is times the length of the clump, which is going to be end minus start. And I know this will work because all the values in the clump are the same. So I can just multiply 1 by the number of values I have. Sorry, not nums I, but num start. And then all I have to do is say two possibilities. Either group sum, either I do include it, so target minus value of clump, or I don't include it, so groupSumClump start plus 1. Oh, sorry, so I don't want to do start plus 1, I actually just want to do end, because end is the index right after the clump. So I want to do end nums, and then just target. And I think that will do it. Okay, so yeah. Alright, so yeah, that is how we could do this one. Yeah, I don't think I have much else to say here. Yeah, we're just treating the clump as one, and then this end index is the end of the clump. So yeah, there we go. All right. Is it possible to divide the ends into two groups so that the sums of these two groups are the same? Every int must be in one group or another. Write a recursive helper method that takes whatever arguments you like. Okay, so really try this one because we haven't had a problem like this before where we needed a helper method, or where the problem suggests you use a helper method. And it doesn't tell us the arguments for the helper method. So you can do whatever arguments you like. But yeah, really try and think about this one, because if you figure this one out on your own, I can promise it'll be very rewarding. But go ahead and pause and try this. Okay, so here's what I'm going to do. I'm going to make a public Boolean, um, I'll just call this helper. I'll just call it helper. Honestly, it'll take a number, nums array, and what I'll do is I'll have the group1 sum, called group1, and a group2 sum. And so here's what I'll do. I'll say, and it will also take, let's see, it'll also take a current index where we currently are, index. Okay, so I'll take a group1 sum and a group2 sum. You may be able to do this with fewer arguments, but this is fine with me. And I'm going to try and zoom in a bit here. Okay, so here we go. So you can maybe guess what I'm going to do. Group 1 is going to be the sum of one group. Group 2 is the sum of the other group, and I want them to be equal. So if I'm at the end of my list, I'll say greater than or equal to nums.length. I'm just doing greater than or equal to be safe. I don't know that I need it necessarily, but just to be safe. And then return, well, if I'm at the end of the array, group 1 equals group 2. And by the way, is this saying, okay, so I just had to check if it meant like by divide two groups, it meant like I have to choose like contiguous sections. Like if I draw a line here where my cursor is, do I have to take everything to the left and versus everything to the right? But no, it just means you can put any number in either group. Okay. Okay, so, and then what I'm going to do is I'm just going to either put the number at this index into group 1 or into group 2 and see what happens. So, I'm going to return, so Boolean, I'll say in 1, which will mean in group 1. It'll be if I, basically I'm going to do helper, I'm going to pass the next index, and then I'm going to add to group 1 the value at this current index. Okay, and then in 2 is going to mean if I put it in group 2, so I'm going to say same thing here, but group 1 is going to say the same in group 2, group 2 is going to have now this value here. Okay, and all I need to do is return if I can make it by putting it in 1 or putting it in 2. And I'm just going to return helper nums in this, so the starting index is going to be 0, and the sums, so the groups are both going to start with the sum 0. Okay, so that's how we could do this one here. Yeah, and again, we could take advantage of the short circuiting if we wanted to by doing a little bit of this. Like that, and then we can also do it that way. All right, so yeah, helper methods, and I think on some of the later problems here, you're also going to want to write helper methods, so feel free to do them. All right, is it possible to divide the ints into two groups so that the sum of one group is a multiple of 10 and the sum of the other group is odd? Every int must be in one group or another. Write a recursive helper method that takes whatever arguments you like. Okay, pause and try this one. Okay, so I think I can do this one very similarly to the last one. I'm going to go and grab this helper method right here. And also, let's see, do I need to increase this? No, I can't increase the size. Okay. So, I'm going to zoom in then. Okay, so here is my helper method. So what I'll do is instead of saying, okay, at the end, am I going to ask if are the groups equal? All I'm going to do is ask, okay, is one group a multiple of 10 and is the other group odd? So that means I'm going to need to say, okay, return if one group is a multiple of 10 and the other group is odd. By the way, if you want to check if a number is odd, always do that number remainder 2 does not equal 0. Don't do equals 1. Because it's not equivalent for negative numbers. Negative numbers get a bit tricky, so if you just say not equals 0, that's better. Okay, so sum of one group is a multiple of 10, and the sum of the other group is odd. Now I'm also going to check if, because like group 1 might be the multiple of 10, while group 2 is the odd one, but it also might be the case that group 2 is the multiple of 10 and group 1 is the odd one, so I could change this here and say group 1 is odd, while group 2 is a multiple of 10. Okay, and then same situation, just return helper 0, 0, 0. Okay, and put a semicolon, and there we go. That's how we could solve this one. Now, I'm trying to think, would it also be okay to only check one possibility? Yeah, okay. It would because basically this is trying every single possibility. So um, it's okay to only check for one, like only check if like one group is a multiple of 10 and the other group is a multiple of 2. Or sorry, not, is the odd one. And it doesn't matter if I switch them. Um, because because when I'm doing the recursion, it's trying every possibility. So every number, there's a one, like so basically if you imagine one possibility where, like, let's say these numbers are in group 1 and these other numbers are in group 2. Well, not only is that possibility going to be tested, but so is the reverse possibility, where the numbers that were in group 1 are in group 2 and the ones that were in group 2 are in group 1. So the inverse possibility is also going to be tested because we're testing every possibility here. So that's how we could do this one. We could even remove those. And that's how we do it. All right, the last one here. Is it possible to divide the ints into two groups so that the sum of the two groups is the same with these constraints? All the values that are a multiple of 5 must be in one group, and all the values that are a multiple of 3 and not a multiple of 5 must be in the other. Pause and try this one. Okay, so there's nothing wrong with the good old helper method, so I'm going to do that. So Boolean helper, it'll take the nums, it'll take an index, it'll take a group 1 sum, and it'll take a group 2 sum. And what I'm going to do is I'm going to put all the multiples of 5 into group 1, and then the remaining multiples of 3 into group 2. So if index is greater than or equal to nums, yeah, it says all, okay. So index is greater than or equal to nums.length, then we return if group 1, equals group 2, the sum has to be the same. And then what I'll say is, okay, if the number at this index, nums index, is a multiple of 5, so remainder 5 is 0, then it needs to be included. I'm going to include it in group 1. I'll write that here in a comment. I'll say, okay, group 1 holds all multiples of 5. Group 2 holds multiples of 3 that are not multiples of 5. Okay. So this is a multiple of 5. I'm gonna be forced to put it in group 1. So helper nums index plus 1 and then group 1 plus this number because I'm forced to put it in group 1. And then otherwise, if it is a multiple of 3, I'm going to put it into group 2, of course. So group 1, and then group 2 is going to take this number. And then otherwise I can do either possibility. So I can say, I can either do this possibility or this possibility. I'm not forced to put nums at index into any particular group, and then I just need to return helper nums 0, 0, 0, and I need to fix that thing down there and see. Okay, so that's how we could do this one. So that's the Recursion-2 section. That's like the shortest one we've done so far. Not the easiest necessarily, but definitely the shortest. Okay, so yeah, that is recursion. Um, and I like the problems in this section. I thought they were good. But I won't talk any longer. We have just 4 more sections left. I'll see you next time.